All right, so this is module 7, and if you look at the very front, you'll see the table of contents. So you should be expecting there is no test for this unit, but you will probably have a pop quiz at some point, just to make sure that you're staying on track. All right, so you'll also notice that you'll see the EOC dates at the bottom. Subpart 1 and 2 is on 12/5, and subpart 3 is on 12/7. And we do have the review EOC packet that we're also working on. And then we'll have one other module, and that's solids, that we're going to work on. And then the semester's over. So hang with me, guys. We're almost there. All right, so let's look at our EOC mini packet. Is extra credit. It's due 12/7/18. All right. So make sure you're doing problems on there. We've done problems 5 and 6. At this point, you should be doing numbers 7 and 8. So right here it says structure is inside outside circle. Well, unfortunately, you're not going to be able to do this because you weren't here this day. But we know that O is the center of our circle, and we want to name an arc. So if this is the center of our circle, see how many arcs you can name. So the arc is the part of the circle on the outside. So one arc, we could label BC, and you put an arc above it. Okay. Now, if we wanted to go and extend this arc now to here, you have to be specific because there's 2 ways you can go around the circle to get to BD. So if I just wrote BD with an arc over it, I wouldn't know, do I mean this arc here or do I mean the larger arc going this way? And so what you need is you need a middle point to let you know that we're going from B, we're bypassing C and moving on to D. So if I wanted to name the arc of this circle, I would have to call it BCD. Very similar to how you would label an angle. All right. Now, if I just wanted to go from B to A, I can just call this arc BA. But now if I wanted to go down here to F, I have 2 choices. I could either go this way around or this way around. So if I knew my choice was to go this way, this is the arc I'm naming, then I'd have to choose one of these points to bypass. So I could say BGF. If it was BF, it would be the big friendly giant. Ha ha ha. Okay. Bad joke. Here we go. Now you're going to develop vocabulary. So I want you to look at what something is and what it is not, so then you can figure out what it really is. So if we're looking at a chord, you'll see that a chord is a line segment that has endpoints on the circle. A counterexample would be these don't have both endpoints on the circle and this doesn't have endpoints at all. That's a line. Okay, so you can also just take these words and you can Google it to get your definitions. But you're going to go ahead and make a definition for all the words that are on this page. So a good definition for a chord would be a line segment with endpoints on the circle. All right, the next one is we've got the circle below, and we want to find the measure, okay? So we got to look at the information that we have and move forward. Well, let's think about some things. So we know that a full circle is 360 degrees, and we know that a half circle is 180 degrees, right? So 3/4 of a circle, it's like Pac-Man. Let's see, that's 180 plus this is 90, right? 90, this is 180. So what is that? 270? All right, so that's information we know already before any other work. Okay, so let's go ahead and solve these questions. So it says the measure of A to B. So here we're looking at this little arc right here. That's 70 degrees. And we want to find from B to C. So from B to C is this part right here. And so this is very similar to a triangle or a straight line. So this would be 180 degrees minus 70 degrees. And you should end up with 110 degrees. And you can check your answer down at the bottom, at the very bottom of the page, and sure enough, you get 110 degrees. So this would be 110. All right, down at the bottom it says, let's go with the measure of AB is now 50. So I'm going to erase. All right, and we want to find ACB. So remember, this is what I was talking about. If we're going to go through C, you're literally going this way, A to C and then to B. So I'm not going to subtract from 180 this time. I'm going to subtract from 360 because that's the whole circle. So 360 minus 50 equals 310 degrees. Okay. And now if I'm looking at AB, once again, this time it's 80 degrees. Ooh. And now I want to find the measure of B to C. Well, once again, I'm going to be looking at half of a circle. So my whole is 180 degrees minus 80 degrees, and I should get 100 degrees. You can go ahead and do the last two on your own, and please note that the last three on your own, and the answers for 4, 5, and 6 are down at the bottom of the page. So you should be able to check your work as you do that. And don't forget, I'm available if you have any questions. Okay, so this is what we did on day 1. So now let's move on, and we're going to talk about, here we go, formulas for circles. All right, so you have this in your notes, and you're going to use these notes to answer questions 1 through 12 on page 7 and 8. So this is page 7 through 8. All right, some things I want you to notice is that if you have an angle, you have a center, and you have an angle, this is what we call a central angle. The angle is equal to the arc. So it doesn't matter where the angle is. If you know the arc is 82 degrees, you will know that the angle is also 82 degrees. So here, this arc from A to B is equal to this angle right here. And then of course, if you have vertical angles, well then you know these two angles are congruent as well, because all vertical angles are congruent. So the key is that a central angle is equal to the arc. All right, so let's go ahead and skip ahead and look at some questions that you're going to have related to this. So you should be opening to page 7, and it should look like this, circle angles. So we'll do numbers 1 and 2 together. So if we look at number 1, we want to know what the arc length is. Well, we know that the arc equals the angle. So here's the angle that we're looking at. This part here is 55, so we know this is also going to be 55 degrees because the central angle is equal to the arc, right? And number 2 is going to look exactly the same. If you know this central angle is 75, then you know this is 75 degrees as well. So you're going to need to do 1 through 12 just like that. Some of them you might have to do some subtraction, okay? So if we're looking at, for example, number 6, okay? For number 6, you want to find the angle from L to M to J. So you're going to start at L, you got to pass through M next, and then come around to J. Okay, so let's take a look at this. We know this is 40. We know this is 110. Now, how can I figure out what this is here first before I can add all my arcs up? Well, we know all the way around the circle is 360. So I know that x plus 110 plus 40 plus 65 plus 55, so the whole circle is going to have to equal up to 360. So if you add that up and subtract from 360, you'll get what x is. And then when you add x plus 110 plus 40, you should get 240 degrees. Okay? So that's the first type of angle, and we call that a central angle. All right? And the central angle is going to help you. So if you need to refer back to this page, please do, and then go back and do your problems. All right? Now there's another kind of angle, because we're talking about all things angles right now. So if you go back to page 4, we're going to look at the second half of page 4. And this is called an inscribed angle. Please note that for an inscribed angle, you have the vertex on the circle as opposed to on the center of the circle. So we're now on the circle making an arc. And what you'll know is that the angle is half the arc. So angle ABC equals 1/2 of 82. So half of 82 is 41 degrees. Now if you want the arc, so the measure of the arc AC is going to be twice the measure of the angle ABC. So if I take 41 times 2, then I get 82, which is the arc. So if you're looking for the arc, you multiply by 2, and that's basically what everything says here. So if I'm looking at ACB, this whole part here, we know is 180 degrees. So half of that is 90. All right, sometimes you'll see it look like a quadrilateral. So if you see a quadrilateral and you're looking for x, you're going to look at where x makes the angle. Here's the arc right here. And you would take half of that. Okay? If you were looking for y, you would extend your angle out this way, and you'd be looking at this arc here, if you're looking for y. Once you find the arc, you would divide it by 2 to get the angle. All right. And sometimes you'll see it look like this, like a bow tie problem. But again, if you're looking for angle C, you're just going to extend, start at the vertex, and extend the lines out so you can see that you're looking for this arc here. And if you're looking from D, right, you're going to start at your vertex, extend your lines, and now you can see that you're looking for this arc here. And what's interesting about this one is that both of the arcs would be the same. So you can see that C and D are congruent. So these are for problems 13 through 18. Problem 13 starts on page 8. So we're going to flip now to page 8 so I can show you what some of these problems look like. And again, refer back to this for problems. All right, so here we go. Let's look at number 7. No, I'm sorry. We're looking at number 13. Here we go, number 13. So if this is 48, I'm going to extend this out. This is going to be 2 times 48, which is 96. Okay. And again, same thing here. If we're looking for this arc here, this is 56 degrees, so this is 56 times 2, which is 112. So now we know 51 and 112 So this